Okay, class, today we are going on to kinematics. That is, we are going to find out how movement is like with respect to displacement, velocity and acceleration. Okay, first of all, let us take a look at displacement first. Displacement is different from distance. Distance is just magnitude, whereas displacement is a vector. It has got magnitude as well as direction. So displacement can be positive, can be zero, can be negative. Now, you can find more information on page 145 of your textbook. Okay, alright, now if this is the line that the particle is moving, this is with respect to, we take displacement with respect to this point. If the particle is at this point here, it will be displacement 0. If it moves this side, it's positive displacement. If you move the other side, it's negative displacement. Okay, for example, if I have a particle here that is 3 meters, it will be 3 meters from O. If I have another particle here that is 4 meters from O but is in the other direction, we say that the displacement is actually negative 4 meters because it's in the other direction. So displacement is with respect to a certain point. Okay, now in Emaths last year, we have done that if we find the gradient of a distance time graph, you get the speed. Alright, so likewise, if we find the gradient of a displacement time graph, we'll get the velocity. Okay, now velocity, the definition is given on page 146 and 147. You can take a look at the the velocity definition that's given. Now, velocity is represented by v, and v is when you differentiate the displacement with respect to time. It's just that when I find the gradient of displacement, I will get velocity. We differentiate it. Okay? Now, note that when v is 0, when velocity is 0, the particle is at instantaneous rest. That means when v is 0, the particle stops. Okay? Now, acceleration's definition is found on page 148 and 149. Now, acceleration is represented by a equals to, you differentiate velocity with respect to time. Okay? And it's also equals to d2s dt squared. Because v is ds dt, therefore a will be d2s dt squared. But you just know this can already. That means acceleration is the differentiation of velocity with respect to time. Now, note that when a is 0, that means when acceleration is 0, the particle moves at a constant velocity. Okay, constant velocity. Okay. Now, what's the difference between displacement and distance? This is an important concept here. Now, for example, if I have a particle that starts from here and it moves from here, then it turns back here. Now, let's say this is a 3 meters, this is a 4 meters. Okay, now the displacement of the particle from O, the displacement is actually negative 4 meters. That means with respect to O, this is the distance here. But the distance traveled from the start till the end, okay, is actually 3 times 2 because it moves here, move back, and then 4. So the total distance traveled will be 3 times 2 because of here, 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 and then plus 4. So the total distance traveled is 10 meters. So this is the difference between the displacement and the distance. I repeat, if a particle starts from here and moves like that, the displacement of the final position is negative 4 meters with respect to O. The total distance traveled from the start till the end is actually 10 meters because it's 3 plus 3 plus 4. So it's 10 meters. So we have to be very careful down here. Okay? Now, next we move on to example 1. Okay? That is found on page 147. Okay, now the question says this: a particle moves in a straight line so that t seconds after passing a fixed point O, its displacement s meters is given by this expression here. Find the value of t when the particle first comes to instantaneous rest. Now I expand this out so that it's for easy differentiation. We know that velocity is ds dt. Okay, so we differentiate this. Now for it to be at instantaneous rest, v is 0. I equate to 0. I factorize, I find. So you will see that when t is 2 and when t is 6, it is at instantaneous rest. That means it's resting. That means it's not moving. Okay, so t equals to 2. T is equals to 2 when the particle first comes to instantaneous rest. They want the first instance, so it must be t equals to 2. The next time will be t equals to 6. Okay, now part 2, it says that the particle returns to O when t is equals to capital T. Find the value of capital T. Now when t returns to O, that means the displacement is 0 because it moves back to the original position. So I will equate the displacement to 0. I will get t equals to 0 or t is equals to 6. Now this is rejected because this will be the initial part whereby it starts moving. So the capital T will be actually equals to 6. So this will be the answer to my part 2. Okay, now for part 3, I want you to pay special attention. It says that find the distance traveled from t0 to t equals to capital T. That means they want to find the distance traveled from t0 to t6. Okay, now note that in part 1, it says that it is at instantaneous rest at 2 and 6. What does it mean? That means the particle travels from O. When t is equals to 2, it stops. Then it turns back. When it's 0, it stops. Then it turns back. And when at t equals to 6, it turns back again. Okay, so instantaneous rest means it stops and it turns back. Stops and it turns back. Okay, the question say find the distance traveled from t0 to t equals to 6. Now from here to here, t0 to t2, I will have this distance here, and when I substitute 2 into s, I'll get 32. So this is 32. So when it moves back here, it is still 32. They only want until 6, they don't want further. So actually, we just measure from here to here is enough. But take note that after t6 is going to move in this direction again. Okay, so the distance traveled from t0 to t6 is actually here to here. That's why we take a 32 times 2, which will give you a 64 meters. Then how do I know that it's moving in this direction? Now can you see that the expression for v is this? When t is 0, that means when it's first started, actually the velocity it starts with 36. When t is 0, I'll get v as 36. So I know it moves in this positive direction. So it's here, here, here. Okay, so please be careful. When v is 0, that means it stops and then it turns. Alright, so this will complete your example 1. Next, let's look at example 2. Now example 2 is slightly more difficult because example 2 talks about the movement of a particle, but it's in the form of a trigo function. Okay, now a particle moves in a straight line so that at t seconds after leaving a fixed point O, its displacement s meters is given by this particular expression. So this is the expression. First part, find the value of t when the particle first returns to O. Now when it returns to O, means s is 0. Okay, displacement is 0, so I equate this to 0. Now it will give me this equal to 0 or this equal to 0. Because this is never 0, this is rejected because there will be no solution, I will have sine 6t equals to 0. Now note that it is 0 when it is, this is the sine curve, sine is 0 when it's at 0 and pi and so on. So I will take the first value pi over 6 because the question say when it first returns to 0. So the particle first returns to 0 at t equals to pi over 6. So this will be my answer. okay, because this is the first answer that is here. Okay, I will not take 0 because this is the initial position. Okay, t over 6 is 0 because it's the initial position. Okay, now next, part 2. The particle first comes to instantaneous rest at the point A. Okay, find the value of A. When it comes to instantaneous rest, that means V is 0. I will have to differentiate this. Okay, I use the product rule to differentiate, and I found out that it is this particular expression here. Okay, after differentiation, I find that this is the particular expression here. Now, when V is 0, I will equate this to 0. Again, this is rejected because this is a positive value always. And we have this. I divide both sides by cosine 60. I will get this. I'll get the basic angle as this. So for tangent to be positive, I will have first and third quadrant. I will get first, third quadrant. I divide by 6. I get this answer. But the question asks for when it first comes to instantaneous rest. So we have to take the first value, which is 0.234. 0.234. Now, next, they ask us to find the acceleration of the particle at A. Now, acceleration is you must integrate the velocity. Okay? So, velocity is this expression. Acceleration will be, I differentiate it. So, I use the product rule once again. It's quite a tedious differentiation. I will get this. And then when t is 0.23426, that is at A, I sub in the value. I use the calculator. I will get acceleration as this. Okay, don't forget when we sub in, we have to use 5 truncate. Therefore, we get negative 57.7 meter per second squared. The textbook gives you the answer as negative 57.8 because they didn't use the 5 truncated value. Okay, so there's a slight difference here. Alright, so this will conclude your example 1 and example 2 for section 18.1. Okay, now the homework that you'll be doing for me on the foolscap paper will be exercise 18.1, question 2, question 6, question 8, and question 12. There will only be 4 questions that you're supposed to do as homework for 18.1. So that's the content part for 18.1.